Start here. Okay. So what we're going to do is we're going to talk about graphing rational functions. Remember, a rational function is an equation where there is a polynomial in a denominator, also in a numerator. These are our steps that we're going to cover here. The number one is factoring. All of our examples today are already going to be in factored form. So we're going to skip number one for today. Number two is holes. There is actually going to be points of discontinuity where a graph actually skips an ordered pair on the coordinate grid, and we'll talk about that later. There are vertical asymptotes which behave like a brick wall. Graphs want to get closer and closer to the brick wall, but a graph is never going to jump over an asymptote, either a vertical asymptote or like number 4, which is a horizontal asymptote. Graphs will now and again cross a horizontal asymptote, but the asymptote for number 4, a horizontal asymptote, really guides end behavior, and we'll talk more about that. Number 5 are zeros where it crosses the x-axis, so we are going to be looking at x-intercepts. Number 6 is the y-intercept, and this one is pretty important. That one's going to be the actual driver of the graph. So number 6 really determines how we're going to graph our sketch. Number 7, of course, is where we graph it, and number 8, we're going to state the domain and range in interval notation. So let's go ahead and get started. Before we jump in, this is an image off a calculator for this polynomial right here. So this is your rational equation. Notice you have factors in the numerator, also in the denominator. What you cannot see on a calculator are the asymptotes. We have an asymptote right here. We also have another asymptote right here. And remember, an asymptote is like a brick wall. The graph will want to get closer and closer to these brick walls, but it will never cross it. So again, it's going to want to get closer and closer, but these graphs are never going to cross the vertical asymptotes. Another thing that I would like to point out in regard to the vertical asymptotes are what is called end behavior. And remember, you can't see it on a calculator, but these are graphs of functions. And functions in Algebra 2, we're going to go on forever. They're not going to be restricted. So what's missing on all of these graphs are the arrows, because these do go on forever on the coordinate plane. And what I'd like to point out to you is something called same behavior and opposite behavior. And when I talk about same behavior and opposite behavior, I am talking about behavior around the vertical asymptote right here. So if you notice, I wrote the word same because both of those arrows are pointing in the same direction around this vertical asymptote. Then there is something called opposite behavior. And if you notice over here, this arrow along this vertical asymptote is going up. The opposite of up is down. And notice at the bottom of the vertical asymptote, the arrow is going in the opposite direction. So I just wanted to give you a precursor on that before we jump into the actual lesson.